Okay, so on this first one we're just literally redrawing the two overlapping triangles by dragging them out, the left triangle and the right triangle here, here. And the common angle is angle C. All right, so using common parts to prove triangles congruent. That's the CP-CTC property is what they're talking about. So it says given triangle ACD is congruent to triangle BDC. So we're given that the triangles are congruent. This goes back to 4-4, that really long proof that we did, where we proved two triangles were congruent first, and then we used corresponding parts of congruent triangles to get parts congruent of a different set of triangles that we then proved congruent. Okay, so it was one of the longer ones. So this one's kind of in the same vein as that. So we're eventually going to prove, don't write anything down yet, just I want to go through the plan with you. We want to prove CE is congruent to DE, but CE and DE are part of these two triangles that are part of the bow tie. But look at what I'm given in the first step. I'm given that the red triangles here are congruent. So it's kind of a two-stager there. We've got all kinds of colors going on. But ultimately, I do want to prove the two green triangles are congruent. And then I can say that CE is congruent to DE by CP-CTC. But before I do that, I'm going to use the corresponding parts of the big overlapping triangles. So here's how it relates to this lesson. You can drag these out. Oh, I should be using the technology right. So I can take this and this and drag them out, leaving just this in there. There we go. So I'm dragging out triangle ACD, which is right here, and triangle BD, and C right here. And it's stated that those triangles are congruent. So that'll be step one in my proving. So step one is triangle ACD is congruent to triangle BDC. So if I want to prove that the two green triangles in my picture are congruent, are there any sides or angles that the green triangles share entirely with the red triangles? In other words, I've been told that these two triangles are congruent. So I can mark any of the sides or angles of this triangle congruent to any of the sides or angles in this one. Do any of these sides share a side in the green triangle? Obviously not CD, right? That's not going to help me. AC and BD do, yeah. So I can mark AC is congruent to BD. I'm going to use that. I'm going to mark it up here as well. That's part of what I'm going to use, or maybe use, to prove that the two green triangles are congruent. So yeah, AC is congruent to BD. Is there anything else in there that is shared? I think I see one set of angles. You see? In other words, in the red triangles, they are exactly the same angles as what you see in the green triangles. No overlapping, no partial angle. Yeah, it is. It's A and B, yes. So I've got A and B. And I could just do this, just kind of like list all the parts that they have in common. And we may not even use all of them. Okay, but those are true. So we're not going to mark, like C and D get chopped up. So we wouldn't use those. This AD and CB are whole side lengths that don't correspond to whole side lengths in the green triangle. So I think that might be all we'll use, is those two that I've marked in green. So we're going to make that statement like this. We're going to say, number two, angle A is congruent to angle B, and AC is congruent to BD. I'll move out of the way here. So angle A is congruent to angle B, and AC is congruent to BD, and that's by CP, CT, C. And let's mark it here as well. So I've got a side and an angle, congruent to a side and an angle. If I could just get one more piece that fits one of these four in red, then I've got it. Do you see, looking at the green triangles, do you see any other angles or sides you could prove are congruent? Yeah, right at E. So you see if I move it, there's my bow tie. Oh no. Oh no. Now I really wrecked it. Okay, so there's my bow tie in green. But yeah, right at angle E, so we would call that angle AEC. So you can say angle AEC is congruent, so AEC is congruent to BED by what? Yeah, that is going to be by vertical angles. So we've got these guys, and then looking at the picture at the top here, which of the four red congruence postulates or theorems will prove the two green triangles are congruent? Side is not in between the two angles. It's one of the two AA. It has two A's in it. It's AAS. So the triangles are congruent by AAS. So I can do this without the picture. It's magic. I've already thought about the correct order with these angle markings here. So I'm just going to change that to a triangle marking. So triangle AEC, so triangle AEC, just changing the angle marking to a triangle marking here, is congruent to triangle BED by angle, angle, side. And then, man, you just did like 9 of these proofs. We went through the same process. What do you think the last reason is going to be? CP, CTC. I mean, if you look at what are we trying to prove? Parts are congruent, right? So CE is congruent to DE by CP, CTC. So CE is congruent to DE by CP, CTC. I mean, as soon as you see in a proof that we're going to prove parts are congruent, not that triangles are congruent, you already know the end of the story. It's going to be CP, CTC. There's nothing else, right? And the second to last step is going to be something about triangles being congruent by one of these 5. And they're probably going to have vertical angles if it's a bow tie, reflexive property if it's a share side. If they have parallel markings in it, it's going to be alternate interior angles. So it's one of those. It says something about a midpoint and its definition of midpoint. So hopefully we're picking up on hoping for good test scores. So you don't have to do any retakes. That'd be awesome. So that's a little more complicated proof, the overlapping triangles. I have one more to do here with you, and then I'll put the homework up and you can get going on it. Separating overlapping triangles. So we're eventually going to prove that BD is congruent to FD. That's what we're eventually going to prove. Now, those little segments are part of this little bow tie right here. But unfortunately, the parts that they tell me are congruent will help me to prove these larger triangles. Let's see, CAD here and here are congruent. So we're first going to prove that those are congruent. So here's what I have. If I separate them out, I've got this guy right here. That's A, C, D. And then right underneath it, I've got A, D, E. So that's separating out the two red triangles. Okay, so here we go. We have a given. We have angle CAD is congruent to angle EAD, and angle C is congruent to angle E. You guys can copy that down without looking up here, right? We're just copying the given down. So copy the two given statements down, right? Number one given. And then I like to go mark them in the triangles that we're trying to prove are congruent. So angle C is congruent to angle E, and angle CAD is congruent to angle EAD. So that's what we have so far. And then these two triangles do share a side right here. So we can say AD is congruent to AD. By reflexive property. AD is congruent to AD by reflexive. So then I can say that triangle CAD is congruent to triangle EAD. And that is by, it's looking like angle side to me here again. Then I have to ask the question, you know, what pieces are shared in the green triangles and the red triangles? So I've got an angle here and an angle here that are shared, those two angles. And I have one other side length in the red ones that are shared entirely in the green ones. Do you see which ones they are, which two they are? Little short guys in there. Yeah. Oh, yeah, it's these two here. It's this guy here, the CD, and the DE. So you can make the statement a CD is congruent to ED by CP, CTC. So I have an angle and a side, congruent to an angle and a side. Do you see the bow tie in there in green? You see it here, but I make a mess of it. There's our bow tie, you see that? Bow tie. So I do have these angles, it's so small, sorry, that are congruent. So angle BDC is congruent to EDF. Number 5. Number 5 is angle BDC is congruent to angle FDE. That's by vertical angles. And then you can prove the little green triangles are congruent. So number 6, triangle BDC is congruent to triangle FDE. That's by angle side angle. And the final step is to prove the parts are congruent. So we can say BD is congruent to FD by CP CTC. That's about as complicated as the proofs would get. So the entire assignment is not like that. Yeah. So don't, I'll show you. I'm going to put it up here in just a minute. Don't pack up yet.